Good morning, geometry students. Have you brushed your teeth today? It's a legitimate question. Oral hygiene is important. Have you brushed your teeth today? Think about that. Onto the math. Today's Flipgrid question of the day is there. Go answer it. It's good fun. You've already found the YouTube lesson if you're watching this. Now, try that problem in your notes. Pause the video, do that problem in your notes, and then unpause it and do it with me. Okay. Alright. Find the area of the regular polygon. That word's important. If this is not a regular polygon, this is going to be a lot harder to find the area of this thing if it's not a regular polygon. So, remember that the area of a regular polygon is 1/2 the apothem times the number of sides times the side length. So, all we have to do is plug in those numbers. I know the side length, I know the length of the apothem, so I need to know how many sides there are. 1, 2, 4, 9, 10. There are 10 sides to this thing. I'm going to erase that so I can see what the picture looks like. Alright, so that means the area is 1/2 the apothem times the number of sides times the side length. So, woo! 1/2 times 12 times 10 times 7 is... I swear I didn't plan that. is 420 units? Don't know. Don't know what the units are, but we know that they're squared because we are in 2 dimensions. So 420 units squared. Squared because we're talking about area, and area is 2-dimensional. Alrighty. Fantastic. That is a review of last time. Let's move on to what we have for today. Today, we have 2 sections combined into one. Don't worry, it's still not going to be that much. We are going to look at the volumes of prisms, cylinders, and pyramids. So just 3 things that we're going to look at, not too bad. So our essential questions are, how can you find the volume of a prism or cylinder that is not a right prism or right cylinder? And that means that they're not perfectly, it means that they're not perfectly straight up and down. It means what if they are kind of slanted like this? Then what happens? How can you find the volume of this versus the volume of that? Is it possible? And then how can you find the volume of a pyramid? So, our learning target today is, you need to know what prisms and cylinders are. Maybe you already know that. Good for you. But you need to be able to find the volume of prisms and cylinders. So volume is the goal of today. Yes. So first, we're going to look at 11.5, then we're going to look at 11.6. So how can you find the volume of a prism or cylinder that is not a right prism or cylinder? How can you find the volume of the ones that look like that? Okay, so first, some vocab is necessary. You do not have to write this down unless you want to. If you don't know what volume is, write this down. But if you're like, volume, yeah, I remember this from 7th grade or whatever, then fine, don't write it down. So volume is the number of cubic units contained in the interior of a solid. So I put this in my own words. Volume is basically the amount of stuff inside of a solid. It's kind of like how much space the object takes up. So if I were to pour water into this prism, into this box, how much water would it take to fill the box? That's the volume. If this is a solid object, how much solid stuff is in there? Of course, we're not getting into density, we're just talking about volume. Yes. Yes, okay. So, more vocab. And again, only write these down if you didn't know what they were before now. If you know what they are, you don't need to write it down. A cylinder. Cylinder looks like that. It's like you take a circle and just whoop, and just take a circle and make it longer. Make it 3-dimensional. And a prism is a polyhedron, that's a fancy word, that has two parallel, that's important, parallel identical bases. And the lateral faces are parallelograms. So, and yeah, you can see this is what they mean by lateral face. And the bases can be whatever they want. They can be triangles, they can be trapezoids, they can be decagons. They can be squares, rhombuses, whatever you want. Whatever you want, as long as they are the same. So anything that looks like this could be a prism. A cube is a prism. My drawing skills fail me. There we go. A cube. Cube is also a prism. Alrighty, so now let's get into the actual volume of a prism. So we're going to learn how to find the volume of both of these types of prisms. The volume of a prism is right here, and you need to write this down. The volume of the base times the height. Now that looks very similar to the area of a parallelogram. The area of a parallelogram is base times height. Notice how this base is capitalized. We have lowercase b versus uppercase b. And the capital B is the area of the base. So we're talking about this when we use the capital B. We're talking about the area of the base. So here, this is our base. And all we have to do is take that base times the height. And you might be thinking, that seems too simple, that seems too easy. But think about it this way. If you know the area of this base, say it's 2 by 2 units, so you have a square here. In order to find the volume, you're just stacking. It's like you're just stacking these on top of each other to find the volume, right? So now you have 3 of these, or excuse me, you have 2 of these, 1, 2. So this is 2 units tall, 2 units long, and 2 units wide. So I do my length times width times height that you already know about. You do the 2 times 2 times 2, and you get 8. This is why the volume is base times height, because you're just taking that same base and you're putting it on top of itself, like this. So, volume is base times height, and I hope this picture helps you understand why. Now another very cool thing. This box down here talks about Cavalari's principle. This is fascinating. The volume of this prism and the volume of the slanty prism are exactly the same. Exactly the same. And that's so weird because they look so different. It doesn't seem like these should have the same area. It seems like they should be different. Because it looks like this one takes up more space. But here's what Cavalari's principle says. If 2 solids have the same height, which these do, and the same cross-sectional area, what that means is this purple parallelogram right here, and this purple square right here, every time you take a slice out of this object, like this, every time, get a different color in here, every time you take this slice, and then you look at this slice, any slice you take out of these guys, if you slice it there, if you slice it there, the cross-sectional area is the same. This square has the same area as this parallelogram, because area is just base times height. So, because they have the same height and the same cross-sectional area at every level, they have the same volume. Woohoo! Okay, if you didn't understand any of that, don't worry, you can rewatch the video if you want to understand, or you can talk with me during office hours if you want to understand. But basically what we're saying is that this works for both these and these. And that is a very, very magical thing. So volume equals base times height. let's put that into practice. So up here, I'm going to put volume equals base times height. Put it right there so that we don't forget. Some little hearts around it because it's very important. Okay, perfect. So, if volume equals base times height, first things first, what's the base? What is the base of this prism right here? Well, the base is this triangle right here, because remember the lateral faces have to be parallelograms. So, this can't be the base, because think of it this way, when you put the base on the bottom, like if you flipped it over and turned the base onto the floor, the bases need to be exactly the same. So here, I have two triangles that are exactly the same right here. So these are the bases. If I tried to use this as the base, if I flip that down, it just goes up to a point. So that can't be the base. So the base is this triangle right here. It is very important that they gave us this right angle here, because remember this is when the capital B there is the area of the base. And remember, the area of a triangle is 1/2 base times height. And because I have this right angle here, I know I have the base and the height right here. So 1/2 3 times 4, which is 1/2 of 12, which is 6. So my capital B is 6 centimeters squared. And my height is 2 right here. So the volume equals 6 times 2, which is 12. Don't forget your units, centimeters squared. Just centimeters? Actually, centimeters cubed, because now we're talking about 3 dimensions. We can go this way, we can go this way, and we can go down. So we're talking about 3 dimensions. That is centimeters cubed. Volume equals 12 centimeters cubed. First we found the area of the base, we found capital B, and then we just plugged in our height. Bada bing, bada boom. Alright, another color here. This one, so remember, volume equals capital B times the height, so the area of the base. Now our base here is a trapezoid. Our base here is a trapezoid. Who remembers what the area of a trapezoid is? The area of a trapezoid is 1/2 base 1 plus base 2. It's the average of your bases. Basically, you're averaging your bases together. Times the height. So, if I plug this in, let's see, this is one base. So this is one of the bases. This is the other base, and then this is the height right here. So let me plug those things in. 14 plus 6 times 3. So let's see, 14 plus 6 is 20. So 1/2 times 20 times 3. 3. This is equal to 30 units. Centimeters squared? Cubed? How do you know? Remember, area is 2-dimensional. Area is 2-dimensional, volume is 3 dimensions. Yes. Okay, so this is our capital B right here. So now we just plug that in, we plug the height of the prism in, and we can get our volume. So we have 30 times. Now don't get your heights confused. This height right here was the height of the base. It was the height of the base. So it was this length right here, or this length right here. The height of your prism is different. This is the height of the trapezoid, and this is the height of the prism. So the height of the prism is 5 centimeters. And 30 times 5 is 150 units. Centimeters square volume. We're talking about volume, so this is centimeters cubed. Ta-da! When in doubt, use your volume is the area of the base times the height. And alrighty, let's move on. Ooh, the solution. Let's see. 12 cubic centimeters. Were we right? Boom. 150 cubic centimeters. Boom. Check, check. Yeah. Alright. Moving right along here. Halfway done with 11.5. Volume of a cylinder. So the volume of a cylinder is, again, the volume of the base times the height. That's a theme for all. Anything that you can take the base of and just stretch. Base times height. So, and the base of a circle, of course, because cylinders have circles on the top and bottom, pi r squared is the volume of the base. So, pi r squared h is the volume of a cylinder. Write this down. Make sure you have written that down. Now, Cavalari's principle applies here as well as to prisms. So just because you have a slanted cylinder, it still has the exact same area as a right cylinder. A right cylinder just means that this stands perfectly straight up and down like that. Okay, yeah. So volume equals pi r squared h. That's the main takeaway from here. Main takeaway. Alright, let's do some examples. Volume equals pi r squared h. And again, remember, this is the same thing as the base times the height. So all you really need to remember is base times height. And then you can find the volume of any prism or cylinder. Okay, so pi r, remember r is the radius, and the radius is 9, so we have 9 squared, and the height is 6, so times 6. And we can put this in exact form, our answer. We can put our answer in exact form or in approximate form. I'm going to do both. So I'm going to do 9 squared times 6. So this is 486 pi feet cubed. Don't forget your units. Cubed because we're using volume. And now if I want the exact answer, I'm just going to multiply these two together. Pi times 480. So this is approximately 1526.8 feet cubed. So both of these answers are correct. This one is exact. This one is exact, and this one is approximate. Whichever one you want. But your IXL might ask for it in exact form. So be ready for that. Okay, next problem. Volume equals pi r squared h. Pi 4 squared times 7. So again, let's keep it in exact form. So 4 squared is 16 times 7. This is 112 pi. And if I multiply 112 times pi, we get approximately 351.9 centimeters cubed, because volume is three-dimensional. So again, both of these are correct. This is just your exact versus your approximate. And yeah, there you go. That easy. Remember these. Remember these. And 526.81 cubic feet, beautiful, and 381.86 cubic centimeters, beautiful. Okay, next. All right, this is going to go quicker because there's only one. We were looking at prisms and then cylinders. This only has pyramids, so this is going to go quicker. Alrighty. How can you find the volume of a pyramid? I am so glad you asked. Like this. 1/3 base times height. Volume of a pyramid is 1/3 base times height, where B is the area of the base and H is the height. And again, it doesn't have to just be a right pyramid, it can also be a slanty pyramid like this as well. So yeah, write that down. Pause the video, write that down, we're moving on. Finding the volume of a pyramid. Well, remember, volume of a pyramid is 1/3 base, area of the base, times height. Now remember, pyramids can have any shape of base. I could take a square base and make a pyramid. Oh, that's ugly pyramid. I could take a hexagon base and turn it into a pyramid. I can take any sort of base and turn it into a pyramid. So make sure that you're looking at what your base is. Our base is a triangle. So I'm going to look for this B first. And remember, B is the area of the base. An area of a triangle is 1/2 base times height. Base times height. So 1/2 4 times 6 is 1/2 of 24, which is 12. Meters squared. Squared because we're dealing with area, and area is 2-dimensional. And now we're going to take this bad boy, put it in there for B, so we get that volume equals 1/3 of the base times the height, which is 9 meters. So this is 1/3. 12 times 9 is, I should have remembered that. But remember, don't should on yourself. So I'm not going to say that I should have remembered that. I didn't, and that's okay. And 108 divided by 3 is 36 units. Meters cubed. Meters cubed. Ta-da! And there you have it. There you have it. Let's check to see if we were right. 36 cubic meters. Oh yeah. Heck yeah. Alright. That's all I have for you today. Volumes. Volumes of lots of things. Pyramids, prisms, cylinders. If you run into any problems on your homework, or if you had any problems with this lesson, what should you do? What should you do? Talk to Mrs. Dodge. You should ask your questions. You should ask. I am here to help you, and I want to help you. Even though we may not be in the same classroom together, I am still here to help you. So remember, you can contact me through email, through my school phone number, which has been posted. I've emailed it to all of y'all several times. And our Google Meet link. That's our office hours. Which, do I have those every Tuesday through Friday? Do I have those every Tuesday, every Wednesday, every Thursday, and every Friday? Do I really? Yes. Yes, I do. And can you really pop in any time between 12:30 and 3? Yes. Yes, you can. Tuesday through Friday, 12:30 to 3. In the Google Meet link. In the Google Meet link. Please come ask your questions. There's no such thing as a stupid question. And I love answering questions. Okay. Moving on. Here is your homework. Not too bad. Volume of prisms. Volume of cylinders. Volume of pyramids. Only 10 questions. Only 10 questions. Oh my goodness. You also have the opportunity to get 8, right? 1, 2, 3, 4, 5, 6, 7, 8. Yes. 8 points of extra credit. You have the potential to get 8 points of extra credit. Yeah, these are not that hard. So I would suggest that you try them. Well, I shouldn't say they're not that hard. They're not that complicated. So I suggest that you try them. But of course, if you're crazy stressed, don't overload yourself. Here is your launch for today. It comes from Oprah. And she says, if you look at what you have in life, you will always have more. Now, of course, this does not mean that if I look at what I have in life, I have a calculator, I have a stylus, now I have a Lamborghini too. No, that's not what this means. It doesn't mean that you will have more when you look at what you have. But what it means is that when you focus on what you have in life, if I focus on the fact that I have a good job, I have friends that care about me, and I have a husband that I'm very happy with, when I focus on those things, instead of, well, I could have a husband that makes dinner every night for me, or I could have a really nice car, but I don't. Like, if I focus on all the things that I don't have, of course I'm going to be unhappy and I'm going to want more things. I'm going to want wireless headphones, and I'm going to want the latest phone because this isn't an iPhone X13 or whatever they're coming out with. But if I focus on what I do have, that this phone functions. It takes nice pictures, it lets me call the people that I want, and it lets me play Clue with my husband. So if I focus on what I do have versus what I don't have, I'm going to be much more thankful and content in my life. So, and you want to be content with your life. You don't want to constantly be unhappy. Of course, you want to set goals, but you don't want to be unhappy with your life. So, focus on what you have instead of what you don't have, and it will feel like you have more. You'll feel more content in your life. So, that is my launch for you today. Take it with you as you go throughout your day. Have a wonderful rest of your day. And thanks for watching. Thanks for being here. Bye.